Despite more than a century looking for a cure, tuberculosis remains one of the leading health problems in the world.
Today, even though many people in the United States think that tuberculosis is not a large problem, in actuality, the World Health Organization has estimated that about 1/3 of the world's population is infected with Mycobacterium tuberculosis, which is the bacterium that causes tuberculosis. And every year, almost 2 million people die worldwide of tuberculosis. And so, although it's a fairly well-controlled disease in the United States, in other parts of the world, especially in developing countries, it remains a really significant health threat.
The need to develop a vaccine has never been greater. One of the more recent problems with TB is that it is also found in many people infected with HIV, causing a double threat.
In many of the countries of the world where HIV infection is very prevalent, tuberculosis, the disease of tuberculosis is also very prevalent, and the two diseases act synergistically, so that it just doubles the impact of both of the diseases.
The first line of defense for physicians is often to treat TB with antibiotics, but TB has often turned out to be a smart opponent.
There are antibiotics that are quite effective at treating tuberculosis, but all bacteria are very clever, and always there will be bacteria that will be able to figure out or to mutate to become resistant to whatever antibiotics that we're able to develop. And so a much better way, I think, and a number of us think, to combat a number of infectious diseases is to develop vaccines to prevent the infections.
Josie Clark Curtis is a researcher at ASU's Biodesign Institute. She leads a team that is working on a research project to better understand TB, with the ultimate goal of applying that knowledge toward developing a better vaccine to stamp out TB from the globe.
We don't understand all the things about how people who are infected but aren't manifesting disease actually develop active disease. We're very much interested in understanding how Mycobacterium tuberculosis is able to cause disease. So that part, the basic pathogenesis part, is one aspect, and then the other aspect is in collaboration with my husband, Roy Curtis. We're also trying to develop a much better vaccine against Mycobacterium tuberculosis.
In a clever feat of genetic engineering, Curtis's group has enlisted the leading cause of food poisoning, Salmonella, to develop a better vaccine against TB.
What we're doing is asking the Salmonella to kind of act as a factory for producing these antigens or these proteins from Mycobacterium tuberculosis, using the genetic information that originally came from M. tuberculosis.
Using Salmonella as the key vaccine delivery vehicle provides a low-cost and powerful new way of treating TB, especially in the developing world.
Salmonella actually provides a number of really distinct advantages, and one of those is that because, as I mentioned, it goes normally through the gastrointestinal tract, so the vaccine can be administered as an oral vaccine. In the developing world, this is really critically important because you can keep the vaccine at room temperature. You don't need to worry about having sterile needles or reusing any needles, and so it really it makes distribution of the vaccine far superior to many of the ways that other vaccines, that many of the currently available vaccines are given.
For Curtis, the discoveries of basic research can be applied to making more effective treatments in the fight against TB, a soon-to-be reality.
By understanding, and by some of the studies that we're doing on the basic science, we may very well, and we certainly hope that we will be able to identify new proteins that could be used in our vaccine constructs. Also, by understanding what we call the physiology or the metabolism of the bacteria when it's growing inside of a human, we may be able to identify different kinds of pathways or different kinds of proteins that could be developed into targets for new antibiotics that might be effective against TB.